so when you make the grid size smaller, you will have millions of computations, and the time step also becomes smaller if you are increasing the resolution. And so you need powerful computers to do this. And in fact, one of the fastest computer in India is at IITM. Now we have a 20 petaflop machine. So to run this, and this is just the atmosphere, but if you are going to control the ocean, that further adds the greater complexity to the whole system. Sorry. Yeah. So the computational complexity increases. You need the supercomputers, and within a grid, suppose my grid size is 50 square kilometer, there are processes happening within the subgrid, like there may be clouds, there may be turbulent process, there is other atmospheric chemistry process. These are subgrid, and that you cannot solve them explicitly. So these are represented by what are known as physical parameterizations. There are various approximations involved, and that's a source of uncertainty. And in India, we developed one of the Earth system models at our institute, known as the IITM Earth System Model. This has contributed to the coupled modeling intercomparison program in the last assessment report of the IPCC. So we participated in the IPCC for making the climate change projections, and we are now getting ready with the next version, known as the IITM Earth System Model version for the 7th assessment report, a slightly higher version. So we have to, and these reports, IPCC reports keep coming every 7 to 8 years. So we are preparing our model for the next IPCC report. It's a higher resolution, some more sophistications are there. I'm not going into the details. And we have used this model to make also a climate change assessment report for the Indian region. And this was a report published from the Ministry of Earth Sciences in 2020, looking at the changes in the land or the ocean or the Himalayas and so on. This is an open access book which is freely downloadable. And as I said, climatic variations can occur due to natural processes like sun-earth orbital parameters. And this was discovered by a Serbian scientist known as Milankovic. He noticed that changes in the eccentricity of the orbit, which happens, periodicity is about 100,000 years. And likewise, the tilt of the axis can also vary with time. And that happens over a time scale of about 40,000 years. And the last one is the precession, that is the shortest, that's about 20,000 year time scales. So these orbital parameters are also changing, sun-earth orbital parameters. And due to that, you can have ice ages, and you can have ages where you are free from ice. Free from ice we call as interglacials, and the glacial epochs are when it's covered by ice. And people have identified this by looking at the ocean deep sediment in the ocean, and they have studied the oxygen isotope delta 18O, and reconstructed these climatic variations for the last 3 million years ago. It's all mostly due to the natural variations. And just to give you about 6,000 years back, what we call as the mid-Holocene. The Holocene period is the entire last 10,000 years. The mid-Holocene was a period around 6,000 years when there was maximum solar insolation in the northern hemisphere. That is when we had abundant monsoon rainfall over India, over West Africa, over East Asia, and many civilizations thrived, like the Indus Valley civilization, Mesopotamia, Egypt, and so on. So you had plenty of solar energy, which is very important for the monsoon, and that was strong, and we had good monsoon, civilizations flourished. Yeah, sorry. And these are some of simulations we did with our own climate model at IITM. We examined how was the mid-Holocene monsoon. So both the Indian monsoon as well as the West African monsoon, the East Asian monsoon were enhanced, both in the precipitation and circulation. This was a PhD of my student, Lakshmi Mudra. But now what we are seeing is we are in an era after the Industrial Revolution. Because of the industrial activities, burning of coal and other fossil fuels, we added a lot of carbon dioxide into the atmosphere, also methane and other greenhouse gases. And this, as I said, these gases can trap the long-wave radiation, and the temperatures have been increasing. And they have happened over a very short, what I showed, the paleoclimatic variations, they are over much longer time scales, tens of thousands of years, or even millennial time scales. But now, these changes, what we are seeing is very rapid. In the last 150 years, the temperature during 2023 was warmer by 1.45 degrees compared to the pre-industrial value. Pre-industrial reference we typically take around 1850. So in the 174-year time period, the planet has already warmed. This is the observed warming, and you can also see at the near surface temperature, the 2-meter temperatures. This is from European Center data set. So the carbon dioxide concentration has been increasing. Now presently we are close to almost 420 parts per million by volume. Carbon dioxide is a very small constituent. It is less than 1%, but that is enough. Even that small quantity, if it is increasing, it can really warm. The pre-industrial value was something like 270 or 280 parts per million. Now we are 420. So we have increased the carbon dioxide by 50% in the last 150 years. And this is a big problem. And because of the temperature increase is not uniform, much of the warming is happening in the polar regions, the Arctic ice, Arctic region, and also in the mid-latitude. So the Arctic ice is melting very fast. And maybe in another 40 years, Arctic can be practically ice-free. That's what they're saying. And extreme events are happening, extreme rainfall events. Typhoons and cyclones are getting stronger. Flooding, because of the heavy rainfall, floods are happening. Even the Antarctica has started experiencing melt, which was not until now stable until recently. The oceans are absorbing a large amount of heat, and ocean temperatures have gone up at greater, even at the deeper levels. So climate change is already happening at a very, very fast rate. And because of these main three gases, the carbon dioxide, which has increased by about 50% compared to the pre-industrial value. The methane has almost tripled. It's going very, very fast. Methane has, of course, has a shorter lifetime, about 12 years or so. Carbon dioxide can be there for several centuries. So it has a very long lifetime. That's the biggest problem. And nitrous oxide is also a powerful greenhouse gas that is also increasing. And now what we have done, so when these gases are increasing in the atmosphere, greenhouse gases, we have added, and on the other hand, there are also particulate matter like aerosols, suspended particles, which reflect the incoming solar radiation, and they can cool the planet. So aerosols can basically, so there are also natural aerosols like volcanic eruptions and sea salt, but also a lot of industrial emissions due to human activities, anthropogenic changes. Aerosols are emitted due to transport and due to industrial emissions. So aerosols, they try to kind of cool, they kind of compensate, but still when you look at the net compared to the greenhouse gases and the aerosol, but the aerosol lifetime is very, very short. We have to keep that in mind. Greenhouse gases have a longer lifetime. Totally what we have added to a warming of what we call in the terminology as radiative forcing, we have added about 2.72 watt per meter squared compared to the pre-industrial time. That's a huge amount of energy because that has been added into the system because of the human activity. So temperature is increasing. And this is the famous person, Professor Suki Manabe and Klaus Hasselmann, who were given the Nobel Prize in 2021 in physics for their pioneering contribution. So Manabe developed a simple model in 1967 with Weatherall, which is known as the radiative convection. It's just a one-dimensional model of the radiation and convection. And he argued that when you have, they also did one experiment where they doubled the carbon dioxide in the model, and they showed how the temperature of the planet, once you double it, will increase more than close to 2.3 degrees. And also the troposphere will warm, whereas the stratosphere will cool. And they also found out because of the water vapor changing the water vapor feedback, the hydrological cycle, water cycle will intensify. And later on, Klaus Hasselmann tried to develop fingerprint. How do you detect the signal due to global warming, due to human-induced climate change versus the natural forcing? And this is a very landmark contribution from meteorologists from the climate community. And this is the famous paper by Manabe and Weatherall that led to the Nobel Prize. And I will not go into details. And I had the good fortune of working with Professor Manabe in the Frontier Research System from 1998 to 2010. And I was in the global warming group. He was my big boss. And this is Professor Masato Sugi, with whom I work. Also, Taro Matsuno, who is another legendary figure. And we also have Dr. Behera San, Swadhin Behera, who's from Berhampur. He was my close colleague. We all got this award in 2000. I also visited Manabe, Professor Manabe in 2004. I'll not go into details. Now I quickly go through the IPCC assessment of the water cycle changes, and every 6 to 8 years, uh, the Intergovernmental Panel on Climate Change comes out with assessment reports about the state of the climate system, what are the future projections, and what are the adaptation and mitigation strategies to be taken. They come in the form of 3 reports: Working Group 1, Working Group 2, Working Group 3. And Working Group 1 is for the physical science, which I was associated. Working Group 2 is on impacts and adaptation. And Working 3 is for the mitigation problem, how to mitigate the greenhouse gases and other forcing agents. And basically, I was involved in the chapter 7 on the water cycle changes. The chapter 2, 3, 4 are on global, the observed changes, the human influence, and that is the detection attribution. Then future projection is chapter 4. And chapter 5, 6, 7, 8, 9 are all process-based studies. And I was in chapter 8 as water cycle changes, which I will be describing. And there are several regional chapters linking global to regional climate change, weather and climate extreme, and climate change information. And it's a wonderful report. They came out with some very powerful statements, and this has to be approved by all the countries in the world, and it's a big process by itself. So the changes that we are seeing in the climate, they're widespread, they're happening at a very fast rate. And it's intensifying and unprecedented in thousands of years. And it is not only the atmosphere that has warmed, also the ocean and the land, and the changes are rapid. And also the cryosphere and biosphere also has been experiencing impacts of climate change. And what we do in these things is all these models, Earth system models from different groups, including our own. We make the same set of experiments with and without the human, with and without the anthropogenic force. Anthropogenic means human-induced changes in the carbon dioxide, aerosol, land use change, deforestation, and see how the climate has responded. There were about 56 models from different countries, and what we show in this picture is this is the observed. So the left panel is the observed increase in the temperature that you see, which is happening very rapidly. And in the right panel, you see that when you have the greenhouse gases and the aerosols, we are able to account for this warming. But if you don't have the control experiment, only the natural forcing, you cannot explain this warming trend. And there are some episodes of cooling. These are associated with the big eruptions like the Pinatubo volcanic eruption, and also we had the Agang in 1983. And these eruptions can throw some aerosols into the stratosphere, mostly in the form of sulfates, and which try to reflect the incoming radiation and cool the planet. But those are very temporary. But the long-term warming trend can be explained only when you have these greenhouse gases. So human-induced forcing is already happening. And there are also aerosols due to human activities, what we call as the anthropogenic aerosols. They have also produced some cooling, but that cooling is magnitude is only small. It's about 0.4. So totally, if you look at the kind of warming that has been contributed, so if we did not have this aerosol, our planet would have already warmed by 1.5 degrees. Right now, at the time of the IPCC report, when the warming was about 1.1 degree, mainly because of the greenhouse gases. And so it is over the land, over the ocean, over the continents, different areas, different continents are warming. So different regions, all the regions in the world are warming. And when you look at the precipitation changes, when you look at the much of the precipitation increase is happening. Is happening in the mid-latitude and the higher. These are when you look at the. This is from the precipitation in the 60 to 90 degree band. And this is the global precipitation. Much of the increase in the precipitation is in the higher latitudes that we are seeing this increase in trend. And the Arctic ice is declining, and recently the Antarctica has also started declining. I'll go pretty fast. And so it is affecting every region of the earth in multiple ways. and in future this will further increase. Uh, so these are some of the changes. This is the observed temperature based on the observed data, and these are simulated by the CMIP6 models. So you can see the temperature increase is mostly in the higher and polar regions and the high latitudes. And this is for the present 1 degree global warming. But when we are looking at the global warming of 1.5 and 2 and 4, you can see the same pattern, but the magnitude of warming in the higher latitudes is much, much higher. So the warming is not uniform everywhere. That's what you have to keep. So tropical areas, the warming magnitude is less compared to the high latitude. I'll come to those details later on. I'm going a little fast. And the precipitation is also going to increase in many high latitude areas with future warming. Our monsoon is also going to strengthen, but there is going to be a lot of intraannual variability that we have to keep in mind. Year-to-year variability, and also within the season, variability of rainfall is going to increase with warming. And some of the dry areas like the Mediterranean region, the Sahara, and also parts in Australia, South America, all the subtropical areas are going to get drier. So it's like a paradigm that the wet regions, the monsoon regions will get wetter, and the dry regions will get drier. And so that means those areas will have big water problem. The droughts will be very profound in the Mediterranean and the areas in South America and several areas, Australia and so on. That's a big concern. And we also, how are these? So what we do is in the IPCC, we make these projections based on different scenarios. We call them as the shared socio-economic pathways. I will not go into details. There are 5 pathways. The SSP1 is the kind of sustainable pathway, and SSP5 is a highly unsustainable. It's highly fossil fuel dependent, lot of emissions. So this will fuel economic growth, but this is more sustainable. This is the middle of the road, SSP2, and these are regional rivalries, like because countries like China are competing for, they want to grow economically faster. So regionally, then they are going to have emissions, mostly the aerosols. So this can lead to regional rivalry, and SSP4 is inequality. So these changes in the greenhouse gases, aerosols, they are all varied depending on these different pathways. And what we find is this is how the carbon dioxide concentration will vary. So these are highly unsustainable. The SSP 585, where the carbon dioxide concentration is going to cross more than 950 parts per million, highly sustainable. The SSP 245 is a kind of the middle of the road right now. So this is what we are following right now, and most likely the way it may proceed, this is very likely. If the countries cut down their emissions, probably we may reach somewhere here. But these are very sustainable futures, but these are going to be very, very difficult to achieve. That is the issue at the rate at which it is presently going on. And I'll quickly go through. So we will cross the 2-degree warming. These are the temperature changes, global temperature changes. You can see in the 245 middle of the road, still we will cross the more than 2-degree warming by end of the 21st century. And the 370, 585, we will even cross 3 to 4 degrees. And if we want to limit the 2-degree, we have to follow only these 2 scenarios, the 119 or the 126 sustainable pathway. Even in the 245, by the midterm, that is by 2050, the best estimate will be a 2-degree warming. And one of the, as I said, if the temperature increases, the water vapor in the atmosphere will increase by about 6 to 10%, depending on the background temperature. So a 7% increase in the water vapor, more water holding capacity, it has a direct consequence on heavy precipitation. So heavy precipitation will also increase at the same rate. And we are seeing during the monsoon season, many regions in India, even Orissa and Odisha, and also places like Telangana, Andhra. So the heavy precipitation events are increasing. Yeah. So in the future, you can see that as the future warming levels at 2 degrees, so they will heavy precipitation events will become more common, more higher frequency. Frequency will increase. Also, the temperature extremes over land will also increase. So we have to definitely improve our early warning system. There will be more challenges to the heavy. So these extreme events over India, heavy precipitation events. So we have made a great progress in terms of the tropical cyclones, but heavy precipitation events, forecasting them, they are going to become a big challenge, and flooding events are going to increase because of the heavy precipitation. And so I'll quickly go into the water cycle changes, the chapter in which I was associated as a coordinating lead author with two other authors from France and New Zealand. And here we assess the entire global water cycle, how much water is actually available, the water store that is available. If you see, almost 96% of the water, 96.558% in the ocean and seas, which are not usable really. And ground saline water is about 1.61. So surface fresh water which is available for human consumption, totally that is available is 1.8. But out of the entire surface water, human cannot access, because they are in the wetlands, they are in the fresh lakes, permafrost, biological water. You cannot access them. So what is really available for human is a very, very small portion of the entire 1.8% of the fresh water. So for our human consumption, very limited, is a scarce commodity. You have to keep that in mind. And water is continuously exchanged between the different components of the Earth system, uh, in the form of evaporation from the land, again in the form of precipitation, groundwater recharge, and also by the melting of the snow and the glaciers. So the water is continuously being exchanged across different components, and so the fluxes of exchange, they were also assessed in our report. And so this is the entire chapter structure that we looked at. I especially focused on the monsoon, which is very, very important for us. We looked at the observed changes in section 8.3, and the 8.4 is projected changes. And we also looked at what are the limits to predicting it, what are the nonlinearities, what are the internal variabilities, and so on. So I was all along telling about the greenhouse gases, but aerosols are also an important component, because they can directly affect your hydrological cycle. So if you are going to put some aerosols in the space due to human activity or due to volcanoes and so on, you are going to reduce the solar insolation. And so once you reduce the solar insolation, the evaporation from the surface is going to decrease. So precipitation will decrease. So in fact, the IMD motto is Aditya Jayate Vrishti. Sun is the main driver of rainfall. So if you put anything that affects the sunlight, you are going to get a reduced rainfall. And this picture shows that in the northern hemisphere, mostly Northern America, Europe, and China, a lot of aerosol emissions because of the transport industry, and they were reducing the solar radiation. This is known as dimming, and this is seen in the observations. The model is also able to capture this dimming effect, and because of that, the West African monsoon precipitation reduced basically in the 70s and 80s, and later on there were some regulatory norms in the emissions, which improved the air quality over Europe and America particularly. And also with the continued global warming, the rainfall picked up in the northern hemisphere in summer and more West African region. So aerosols, they try to counteract the global warming. In fact, global warming will try to increase the rainfall, but basically your aerosols will try to reduce the rainfall especially. And so these are from the models, from the CIMIC 6 models, we found out what is the role of the greenhouse gas, what is the role of aerosols on the temperature and precipitation changes. So what we do is the fingerprint, when you look at the greenhouse gases will try to warm, mostly in the high latitude, mid latitude, and the temperature aerosols will try to cool over the continental areas. And so with the aerosol, you have a interhemispheric asymmetry. More cooling, because the emissions are all in the northern hemisphere compared to the southern hemisphere. Southern hemisphere is relatively warmer. The IT season, I will not go into details. So if you cool one of the hemispheres, the IT season will always shift to the warmer hemisphere. And that is why we see increase in the precipitation in the aerosol experiment to the south of the equator. But many areas in the monsoon region, rainfall will get reduced. And with respect for the greenhouse gases, mostly the subtropical areas, because the Hadley cell will get stronger and the Mediterranean and many areas will get drier. And so drought prone areas in the subtropics, so the drought conditions will intensify. So we also assess the different monsoons, so like the south, like the Indian monsoon, the south, some Southeast Asian monsoon, East Asian monsoon, the Australia maritime, West African monsoon, North America, South America, and what has happened in the past, in the historical period, and what are the future projections. I will go through quickly. So what we say, I'm just showing for South Asia and East Asia. Uh, Basically, the rainfall as the global. So once we are able to reduce the emissions, especially the aerosol emissions, but global warming is projected to continue. So as it continues in the future, the rainfall or the monsoon rainfall will increase in the especially in the higher emission scenario. Higher, the 585 is a high emission scenario. So the mean rainfall increase, but also a lot of variability is there. That's what you have to keep. So in the future, this is the near term 21 to 40, mid term 41 to 60, 81 to 20 is long term. So rainfall is going to increase in all in the future with increasing concentration over South Asia, also over East Asia. So so here there is an opportunity. So since the monsoon rainfall is going to increase, can we conserve it? Can we make dams to preserve the water? Because there's also going to be more variability. There may be periods where you may not have rainfall. So you have to keep in mind. And so in the historical past, there was a decrease in the rainfall due to the aerosols in the northern hemisphere. But now this can be changed. So if you cut down these aerosols, China has already done, Europe and North America has done. Now if India also does it, we can reduce the aerosol burden. So this is a policy. So it is good for our health. It's good for the human health because the Delhi air pollution is getting a big problem. So how to reduce the aerosols? If we can do that, it will also improve the monsoon rainfall. And of course, in the future, we are going to have, because of the greenhouse gases, monsoon will increase. Of course, it will be dominated by a lot of variability, and then in the near term, especially, internal variability is going to be an important issue. Uh, and so we have to develop our early warning systems. And these are the key messages for Asia. Temperature will increase, there will be more evaporation, humid heat stress will become more intense over India. So during the pre-monsoon months, we will have this heat stress will be an issue. And both the mean monsoon precipitation and the heavy precipitation will increase in the 21st century with the enhanced intra-annual variability. So there will be more variability also. And one of the other issues we are facing is there's a lot of groundwater that is being extracted for irrigation. It's happening over Northwest India, also parts of USA and China. So global, there is a kind of depletion of groundwater. And some areas like Africa, the rainfall has actually increased. And this has led to an increase in the recharge. This has happened over several decades. So the rainfall increase has led to an increase in the recharge over the African region. Uh, and but by and large, but there are a lot of limitations. We still don't understand how the groundwater will changes will happen in the future. Uh, because so the assessments are not clear, but definitely the extraction for irrigation in many of the world's most agricultural productive areas, groundwater has depleted. That's a big concern. And this was a paper which came from IIT Bombay. What they argued is, since it's an agricultural, it's of interest to the agricultural community, they argued that if you have switching of crops for water sustainability in India's food bowl, yields co-benefits for food security and farmers. So they said instead of going from these crops like rice and which are highly water, they consume a lot of water, you can go for millets. You go from rice to millets and sorghum in the Kharif season instead of wheat. So you can really improve the groundwater because the irrigation requirements are minimum, and so your groundwater will get, it is important for improving the groundwater. Also, they find the irrigation efficiency improves, and so the energy demands are also reduced. So I thought I will highlight this paper, especially in this meeting. So we said that quickly I'm winding up just 2 3 slides. So climate change is already happening. So we have to definitely mitigate climate change, and that's going to take a long time because the greenhouse gases are having a long lifetime. But main problem is water is also getting affected, and anything that you can for the first time. So water is still a blind spot when you talk about climate change policies. It is still a blind spot. We have focused a lot on the extreme events, developed early warning systems, but many areas are going to get drought prone. I will come. This is mostly in the Mediterranean, the subtropical areas. So droughts are going to become a bigger issue. How do you deal with that? So it is now, and also any adaptation strategy, mitigation strategy, or if you are trying to control the temperature, it is tied to water. So water becomes an element. If you want to go to adaptation is closely tied to water. Even mitigation options are also tied to water. So you cannot separate water from climate. So that's what is the main thing. So you have to close the loop. So all the 3 working groups have to work together. That is the main message. And so if you see, with temperature as it increases from 2 degree, 3 degree, 4 degree, the total precipitable water, that is the moisture, integrated moisture, that will increase linearly. Okay. But if you look at the precipitation, it doesn't increase so linearly, annual precipitation. And when you look at the intra-annual variability of precipitation is even more. So you cannot linearly scale. That is one of the challenges. Similarly, runoff over land, it doesn't scale linearly just like water vapor. And intra-annual variability becomes a big issue. And many areas in the Mediterranean and areas in the Australia and South America, droughts are going to increase in the future. So that is a big worry, and water is going to be a big issue. So this is my summary. So already human-induced climate change is affecting many regions, weather and climate in every region. And so the assessment is getting much stronger in 6th assessment report. And water cycle global water cycle will intensify. Also its variability. And monsoon precipitation is also projected to globally, also South Asia will increase. But the severity of the wet and dry events are also going to increase. So wet events are going to become more severe, flooding events will lead to floods, dry events are also going to become severe. And but it will also depend on the circulation changes and so on. And for South Asia, the good news is monsoon will get stronger. So can we use this as an opportunity to conserve water? And water is still a blind spot when it comes to climate change policies. So it's very, very important that we need the scientists and the policy makers. They have to work together to close the loop. How to close the loop between the mitigation options, water cycle changes, and the impacts and adaptation community. So Honorable Prime Minister gave this wonderful speech. I will not get into it. He says one sun, one earth, one world at the COP26. So India is planning to make a net zero by 2070. And but the important thing is, the main message that he said is, so far, for a sustainable future, we have to transition from fossil fuel to solar energy. Mid-Holocene example I gave because directly the solar energy that was intensifying the monsoons, all the civilizations flourished. But last 150 years, what we have done, we have got fossil fuel energy, added more carbon dioxide into the atmosphere, and this problem has happened. So the key for a sustainable future will be to go transition from a fossil fuel energy to a solar energy. And there's an international solar alliance that was proposed. So, and this is important for the energy generation. And there's a YouTube video which is about 6 minutes. I'm not going into this, but maybe you can play. So with this, I want to conclude my talk. Thank you. Jai Hind. Thank you.
There is an announcement. Those who are participating in university poster presentation, university students, poster presentation, there will be evaluation by the jury members. You can move to first floor. Only university students. Poster presentation evaluation will be done in the first floor. Thank you, Dr. Raghavan, for such an insightful presentation. Our next technical talk is by one of the stalwarts in climate science. We have the most legendary personality on climate change and sustainability, Professor Dr. Uma Charan Mahanti, presenting on climate change, extreme weather events, and sustainable development. Before his talk, I want to take the privilege to introduce to our audience. Professor Uma Charan Mahanti is a distinguished atmospheric scientist with a remarkable career spanning over 48 years in teaching and research. His contributions have been recognized with numerous prestigious awards, including Santi Swarup Bhatnagar Prize, National Award in Atmospheric Sciences and Technology, Biju Patnaik Award for Scientific Excellence, and Sir Gilbert Walker Gold Medal. Currently, he is serving as a distinguished professor at the Center of Climate Smart Agriculture, Sikya Anusandhan University, Bhubaneswar. Sir, please.
Thank you, madam, and namaskar to all of you. So I will try to be as brief because we are already crossing the time, so we have to move a little faster. So outline of my presentation that I will give that to the nexus among the climate change, environment, and extreme weather events. And I will tell on the extreme weather events, there are many events, but I will focus mainly on the tropical cyclones, severe thunderstorms, and monsoon. Of course, we have heat waves and many other things that are related. So before going to that, if you see that introduction, I will skip. I will tell that the atmosphere is very, very important for us, for our life. That is what my previous speaker here told, that how atmosphere protects us and the life is here, and our earth is unique, that we have, along with the other things, the water. So now let us see how it evolved in the period of about 4.5 billion years, when we are first over the globe, we got the gases like hydrogen and helium. There is no oxygen and no water. So obviously there is no life. That is what started the atmosphere 4.5 billion years. But both these gases, as you all know, my dear students, that these gases are very light gases we use in the balloon, because these gases are escaped. But after that, we get many volcanic eruptions and also burning of the comets from the other planets. As a result, we get a lot of carbon dioxide, along with that, water vapor. So when our Earth started cooling gradually, because there is no atmosphere, so it is cooling. So due to cooling, then we started getting rain. The water vapor is cooled down and give the rain, and that rain has gone to the low-lying areas, so like oceans, so we form oceans, lakes, and so on. And as well as the first life that came in the water, that is about 2.8 billion years back, and first life is the cyanobacteria. These cyanobacteria, like any other plant, they have the photosynthesis, and all of you know, by the process of photosynthesis, we take the carbon dioxide and give the oxygen. So oxygen started entering into our atmosphere. And there, when you have water and oxygen, you know that we can have the life, because you know that in the inauguration session we told that air and water, that is most important thing. And once air and water is there, and then we have the plants and so on, which gives us the food, then our life survives. And that's how the evolvement of the atmosphere, and within that, actually, as we have told, many ice ages and non-ice ages and so on, and that is the natural change. So when natural change is so much, And now our thing that why you are so much worried for 1.1 or 1.5 degree change due to climate change. That is what we are discussing today. So I will try to project before you that what this 1.1 change which is made, because day to night you have so much changes from desert to the tropical forest. There is so much changes in the temperature. Season to season we have so much change. So why we are worried for this 1.1 degree? If we see our atmosphere, it is not an isolated one. It is linked with the 5 spheres, starting from the lithosphere, that is upper crust of the atmosphere, Earth system. Then we have the cryosphere, we have the biosphere, we have the hydrosphere, and we have the atmosphere. And on top of this, we have the outer space. So these spheres, they interact. We cannot stop them. And over that, our Earth's atmosphere is there, and it is influenced by all these spheres, and they have the interaction in both ways. So I will not go to that, but that is how the linking of the processes. So therefore, we have a strong linkage between climate change, environmental ecosystems, and natural disasters. So my talk, I am focusing actually on the natural disasters, how they are influenced by the climate change of this 1.1 degree. So you see that global warming and natural disasters, they are interlinked, and this is a picture of the 1999 famous Odisha super cyclone. And the friends actually that they change, and weather and climate, you know that weather is an instant value of the happenings like temperature, moisture, rain, and so on. But when climate is the average for a longer time, and generally it is 30 years, that is what we accepted. And fortunately, and we know that these natural disasters, which are really alarming with the climate change, like floods and droughts, tropical cyclone, and so on, fortunately, they are not many. They cover about only 5% of the time and very localized, not the global. So this is what I told you earlier, that this is the 2 types of natural disasters. Of course, we have man-made disasters are there, which we are not discussing. So the natural disasters, they are broadly of 2 types. One is known as hydrometeorological disaster, that means linked with water and atmosphere. And they are like cyclones, floods, drought, tornado, dust storm, heat wave, and so many. Other is the geophysical disasters, which is generally the earthquake, avalanche, landslides, volcanic eruptions, and so on. So if we see that distribution, this is a period, World Meteorological Organization, they took a detailed report of happening of these events around the globe, and you see that the blue one, which is the hydrometeorological disasters, the brick one is the geophysical disasters. Then you can see that the numbers are more than 90% are the hydrometeorological disasters. And these are the weather, water, and climate-related extreme weather events, starting from very short-lived tornadoes and thunderstorms, flash floods, to that of the drought, which can be for a very long time. And like you know that is a drought in Africa, Sahel region, it was for several years. So then let us see what these disasters make us. So if we see the distribution of these major disasters around the world, then flood contribute about 32%, drought about 22%, tropical cyclone about 30%. That means 84% of the major disasters, significant damage caused are the 3 major disasters. If we see the persons are affected, that also depicts the same thing, drought 33%, tropical cyclone 20%, and flood about 32%. Again, 85% of the people that are affected by disasters, natural disasters, are these 3. Then if we see total number of reported disasters, continent-wise, then we the Asians suffer with maximum 43%, followed by America 23% and so on. But then if we see number of people that are killed by the disasters, which is more concern for us, is the Asia, about 80%. So that is the concern, why we have so much casualty in the Asian region, and if these disasters will increase with the increasing the trend of the rising temperature and climate change. So that is what is the issue before all of us. And if we see the cumulative economic loss due to disaster, because one is the loss of the life, other is the massive destruction of the property and so on, and the cumulative one for 20 years from 2020 to 2019, if we see the top one, the red one is the tropical cyclones. Tropical cyclones occur only in the tropics, but the loss due to that is enormous, and then floods and earthquake and so on. So if we add all these things, it is more than what is our GDP now per year. That means the whole income we have from different sources, that is the loss in 20 years around the globe. Global warming evidence, I should not go because it is already told you by previous speakers and so on. And only that I make you remember that this source of greenhouse gases are the energy, and energy that we use by like power generation, energy we use the transportation and the agriculture and land use. Land use, land cover also make a contribution towards the global warming, like release of the methane and so on. And if we see distribution of the greenhouse gases, it is already told that the carbon dioxide is the maximum and followed by the other gases. And then question comes that this change of 1.1 degree, which was really found by the geography people first. At that time, we were not believing that because 1.1 degree change in that 150 years, and then you know that many cities like Bhubaneswar and so on, we have so many concrete jungles, that also rise the temperature. So whether it is real or it is just a man-made local effects like urbanization and so on. But now we know that it is not so, it is a fact. And how to know that? It is natural or man-made. So natural is a change which you have seen from previous presentation, that is due to orbit of Earth around the Sun and the inclination of the rotation of both the Sun and Earth and so on. So how to do it? We cannot separate that. So it is done by a lot of numerical experiments with very high performing computers, and where, again this figure is shown by Dr. Krishnan, that if the anthropogenic effects, that is man-made forcings, which is the main cause of the rising of the temperature, both over the land, ocean and globe. And these things also seen by various indicators, because if the warming is there, because we are telling it is not climate change, we are telling it is global warming. That is the war we started, because the increase was very small, it is gradually increasing. And then actually, obviously if the temperature rises, then you will have the glaciers, snow will decrease, temperature of the land will increase, snow cover will decrease, so all black points, they are decreasing, all white ones that are increasing. That will happen if a temperature of our atmosphere increases. And these all 15 indicators, they confirm that there is going to be these changes. These changes are all observation. So that confirms univocal acceptance by all the community that really there is a climate change taking place, and then we have to do some measure for that. So as you know, this climate or water and weather, it has affected entire life, like the food security, that is the production of by the different type of agriculture and horticulture and so on. Water resources, health, all these things are affected And for that, we have to do the switch over to clean energy. Because energy, that is the whole culprit that all of you know, that is the energy that we are consuming for various ways, from the light and things and electricity to that of the even a power generation or driving the vehicles and so on. So everywhere we use the energy. And source of energy, what we are using today, all of you will tell that it is the petrol, diesel and coal. So this energy, where from we get these things? That we get beneath the earth, which we call in the hell. But there is the alternative energy there, which comes from the heaven. There is the solar energy, enormous energy, that the whole our earth system is moving continuously in the atmosphere, always it is in motion. That is because of the solar energy. We get the water, hydroelectricity. We get the wind, then we get wind energy. So these energy are the clean energy. They never give the greenhouse gases. So therefore, now we have to switch over. That is what the concern of everyone, that now we are using only 11 to 12% of solar energy. Whether we can increase to 30%. Whether we can get water disassociate to oxygen and hydrogen. And as you know, hydrogen can burn and give the energy. Oxygen is fuel it to sustain. So whether we go to hydrogen energy. So therefore, before us, the option is there. And that is the challenge for our future. All my young friends are here. That if we think over like that way, that we get the energy from the heaven, that is this source of energy, that can be replace our energy that we are getting from the hell, that is, then that will be a big contribution to arrest the climate change or arrest the global warming. Then I'll go briefly the global warming and extreme weather events. Again, you have heard a little bit from my previous talk. And one is the tropical cyclone. You know the tropical cyclone is associated with the pressure drop at the center and giving the strong maximum wind, and also it has a track and it gives very heavy rainfall. And tropical cyclone, the name tropical means it is occurs in the tropics only. That is from 5 degrees north to 30 degrees north, 5 degrees south to 30 degrees south. We don't get any cyclone from 5 degrees south to 5 degrees north, because that is the equatorial region. Due to rotation of earth, there we don't get a deflected wind so much, so we get only in this zone. But this cyclone is not occurs only our Bay of Bengal and Arabian Sea, with which we are familiar, but it is across the globe in all tropical oceans. On the average, we get 80 to 100 such cyclones per year, but in Bay of Bengal, we get up to 4 to 5. Arabian Sea, we get about to 2. So almost we get 5 to 7% of tropical cyclones that occur in the entire globe, and it has different names. In Pacific area, we call it typhoon. In the Atlantic area, we call it hurricane. And in our region, we call tropical cyclones. And why I'm showing that, I'll come to next to that. These tropical cyclones have a lot of damaging potential. If you calculate the equivalent energy, the energy associated with the tropical cyclone of 1999 is equivalent to 1,500 atomic bombs that was used in Hiroshima and Nagasaki. That means you can imagine how much energy, and that energy comes as a wind energy. That energy is there. So therefore we cannot kill a tropical cyclone when in the ocean, or we cannot divert it. But we have to face it because it is a colossal energy. But that energy gives to us very strong winds with a number of damages and potential. It gives also another thing, the storm surges. Because tropical cyclones is not only over the ocean. So when there is churning is there in a tropical cyclone, then it is churned, this thing like we churn the milk, then water comes up. And when water comes, then it floods the coastal area, and many people, they just wash away. And third is the heavy rainfall associated with the tropical cyclone, like the cyclone of the Super Cyclone 99. The rainfall in these 2 to 3 days was more than 1 meter. So therefore, water is coming from one side from the rivers, and a storm surge is coming from ocean. So whole coastal belt is flooded, that area affected by tropical cyclone, and many people, they perished, they wash away. So now if you see the distribution of the tropical cyclones for 300 years around the globe, and I am showing only the cyclones having the casualties or death toll more than 5,000. If such cases you will see that the total is how many? 24 plus 7 plus 2. So 33 such cases. And out of that, 24 alone occurred in the Bay of Bengal, where only 5 cyclones per year and 5%. That means we get 73% casualties of larger scale in the Bay of Bengal alone. Most famous one out of them, famous or you can say infamous, is that the cyclone Bhola, which was in 1970 and which crossed Chittagong area in Bangladesh, and more than 3 lakh people perished. Most recent one, the cyclone Nargis, 2008, crossed Myanmar. More than 1.4 lakh people died in single cyclone. So that's why cyclone is considered as the most devastating disasters, and 74% in our Bay of Bengal. Why it is so? Definitely the question. That is due to the storm surges. Out of the 3 major destructive power of the cyclone I told, most affected the people are due to the coastal of the storm surges. And Bay of Bengal is a funnel shape. Water is coming from south to north, then it will pile up. We have a large number of rivers. In Odisha itself, we have 7 rivers, major river systems. So therefore, when cyclone fall in that systems, then it aggravates the issues. So due to storm surges, maximum people, they die in the Bay of Bengal. And our Bay of Bengal tropical cyclones are most peculiar to that of the tropical cyclone we get 95% in other places. Why? Because 2 cyclone seasons. We have the 2 cyclone seasons nowhere except in India, Bay of Bengal, Arabian Sea. One is the pre-monsoon, that is before the monsoon, that is April and May. Another is the post-monsoon, that is after monsoon is over by late September. Then we get October, November, and sometimes in December also, we get some cyclones. So we have 2 seasons. Cyclones are relatively moderate because the energy that cyclone gets, that is, as I gave the example, where from it is coming? It is coming from the ocean. Due to evaporation. Evaporation brings the energy, and then when it condenses, then it releases the energy. And that is the process how the energy comes from the ocean, which is the reservoir of energy, to that of the atmosphere in form of the tropical cyclones. So this energy comes more as the cyclone move longer time over the ocean. So therefore Pacific and Atlantic, they get very, very severe cyclones. But we get moderate cyclones. But our casualty is the highest that I told you, that, and I have shown you the demonstration of the years, and that is mainly the low-lying area, large space of low-lying area, delta regions, and also coastal floodings and storm surges. And now I am coming, this is the observations from 1970 to 2005, that cyclones, like other disasters, like you know that you get earthquake, they tell different scales. Similar way, cyclones also, we have different categories. Category 1 is because you know that when IMD announced, you all know that they tell it low pressure, depression, deep depression, cyclone, severe cyclone, very severe cyclone, extremely severe cyclone, and super cyclone. So that depends upon the intensity of that system. So category 1 is a very low category. Category 2 and 3 little higher, but category 4 and 5 is the severe. Very severe, that is like extremely severe cyclone or super cyclone. You see that in this period, it is shown that from 1972 till now, the super cyclones or cyclones of higher intensity 4 and 5 category, they are increasing very rapidly, but 1 and 2 may be decreasing. So total maybe the cyclones are decreasing due to global warming, but the severe cyclones, they are increasing, which is the concern. Because if a cyclone of low intensity, it has a lot of benefit. It gives a lot of rain, which is always we need, the fresh water. But when it is severe, then it is actually harmful, the loss of the life and property takes place. And this is for different basins, I will not go to that. But if we see that in North Indian Ocean also, we have increased that from the blue to that yellow one, that is increased significantly. And if we see actually the changes of increase of pre-monsoon by 20%, post-monsoon by 59%, on the average about 46% severe cyclone increase. And if we go to Bay of Bengal and make it divided into 3 parts, North Bay, where actually cyclone cannot live more than a day or two, and to that South Bay where it can live for the longer time, then you see that the increase. Here actually it is shown in the red is the severe cyclones, and the solid one is the pre-warming era to that recent years. Then you can see the increase is quite large in the severe cyclones that is which generate in the South Bay, because they get a longer time to pass through from South Bay. They come to us Indian side, many times they recurve and they come all the way to Odisha, Andhra, Odisha and Bangladesh and so on. So this is the 2 periods, that is pre-monsoon and post-monsoon. D means is the depression, CS is the cyclone storm, and SCS is severe cyclone storm. You can see that that is increasing compared to the other. Though we get many depressions and we get maximum disturbance and depressions during monsoon time, that gives us the rain. So the beauty of that depression and this thing is required. If that is not there, we may get much less rain in the monsoon time, which we need more. But the severe cyclones which come in the pre and post monsoon, that gives a lot of casualties. Then comes the monsoon, another. Monsoon, you are all familiar, and India is also unique that we have 2 monsoon seasons. Monsoon, we decide that where from the wind is coming, how much it's changing. If it's changing quite large, then we call it monsoon. We have 2 monsoons in India compared to other places. One is the southwest monsoon or summer monsoon, which occurs in June, July, August, September, all of you know. And that time wind comes generally from southwest. So we call southwest monsoon. Other is that we have winter monsoon, which is the more affected in the south, and the Tamil Nadu and that part. They get less rain in the monsoon time, that is summer monsoon, but winter monsoon they get rain when wind comes from northeast. So we will concentrate on the southwest monsoon because all of you are familiar and you are affected by that. And it has many factors. One of the most important factors, the wind at low level and upper level. Low level you see that the wind is coming from the Indian Ocean and the Arabian Sea and crossing the India, bringing a lot of moisture. And upper level, the divergence. That means to sustain a wind and making it to grow, because it cannot go down. So when the wind is converted, it will go up. But if we make a lead, then it will die. So that it has to go away from that region, and it goes by the upper level flow. So that gives us the onset of the monsoon and the progress, withdrawal of the monsoon. That very unique way distributed around the whole country. And the monsoon, have the summer monsoon, that is until monsoon, it has many semi-permanent features which are associated with that, and that gives a sustained monsoon for us. That is from the low level jet, which we call the Somali jet, to upper level jet, that the outflow, that is we call the tropical easterly jet. And in between that we have the monsoon trough lines, many times, monsoon depressions, and so on. And the distribution of the rain, if you see along the country, month-wise, you can see that in June, July, August, September, they contribute almost 70% of the water, fresh water, that we need for our various activities. Because that is the day we have no water, how it is difficult. This all water, as told by my previous presenter, Dr. Krishnan, is less than 1%. That is the fresh water we get. Otherwise, 97% of the water is there in the ocean, but it of no use. Like Chennai, they purchase water, but next door is the Bay of Bengal. We are fortunate in Odisha, at least we don't purchase water, because we have many river systems, and that gives plenty of water. But how much we make wastage of the water? That is the question. And this water conservation is very, very important, and that have to be done in all the scales, starting from groundwater recharge in each house to that of the water reservoir and so on. Otherwise, we waste a lot of water, and as you know, water is alive, and all our food are coming with the water. Can you tell me any food, vegetarian or non-vegetarian, you can get without water? There is no such. Everywhere we need the water. But we waste the water a lot. And there where actually we have to do a lot of things. And I am telling this because our all future generation is here, and you have to think, because what we have to do. During the monsoon time, also we get very heavy rain spells, that is we call active spell of monsoon, and then we have spell when less monsoon rain, that we call the break monsoon, and again maybe active monsoon. And now we are seeing for a long time records that the number of heavy rainfall days, they are increasing, but number of moderate rainy days, they are decreasing. Because previously that we have the rain for the 10, 15 days, continuously drizzling, and that is very good for the plant. But that is decreasing, and number of heavy rainfalls are increasing, leading to more floods. Similarly, this particular region, a study was made by Goswami et al., and it is science reported. You see that the number of days of less rainfall is decreasing, number of heavy rainfall, 15 centimeters or so, it is increasing. Leading to that, the concept that heavy rainfall for short time, giving the floods, no rainfall for a long time, giving to the droughts. And that is what is the more concern, and global scale also almost in similar pictures. Another is thunderstorm. Now you know, lightning associated with thunderstorm is a major catastrophe. It has associated with various disaster aspects. But if you see the human casualties, that is the record what Odisha government collected from the various sources. You see that every year, now the death casualty due to cyclones have come down. We call that the recent one, Ayla, that our casualty almost zero. But the casualty due to thunderstorms, you almost read every day in the newspaper, some people die somewhere, single person dying due to that is lightning. And this is what in Odisha. But if you see India, almost 2,500 people die per year due to the lightning associated with the thunderstorms. And many times the people die because before you had the thunder, the lightning passed through, and poor farmers work in the field, in the open field, generally they are the victims of this type of thunderstorms, and thunderstorm lightning may be cloud to cloud or cloud to ground. So now, of course, we have started developing the sensors to have a lightning detectors, and thanks to the IITM, the director is here, and they installed 8 lightning detectors in Odisha, and almost we can see the occurrence of those things, and a climatological study show that the number of thunderstorms are decreased over Bhubaneswar and Baleshwar, little bit rise in the Gopalpur. But if we see the heavy rainfall associated with thunderstorms, they are increasing. That means it tells that the intense thunderstorms are more, and they are more in the monsoon period. This casualty which I have shown, though more lightning occurs in the pre-monsoon period, that is June, May, April and May, but casualty is maximum with the thunderstorm that is occurring in the monsoon time, when the really farmers they work in the field, because that's a more dangerous place. So therefore, if we see, actually I will skip those things because my time is almost over, because we have to allow others to speak. So I am showing that this is how it is increased the projections, and this is the impact of major environmental change and hazards, tropical cyclones, intensity increasing, drought, and so on. So then, actually what we should do actually? We have to do something, and thanks to that, actually we have now very good improved forecast, thanks to the Ministry of Earth Science, and under that IMD and few other organizations like IITM, IMD, and INCAS, and so on, many, and NCMWF. So these are the organizations who are involved in various prediction of atmosphere and ocean processes, and observations have dramatically increased, enhancement of the observations, accuracy of the prediction has substantially increased, and along with that, the government has taken measures like the Disaster Management Authority, and Odisha is the first to start a management authority, OSDMA, after 1999 super cyclone. And there is nowhere that. And our National Disaster Management Authority, it came only 2005. So in that way, we are proud that we started that thing, that what measure we should take before a disaster, not that we will do the relief things after the disaster when already people died. So therefore, the success in tropical cyclone forecast is really a proud thing for all of us. And that again we can tell that due to the climate change and its impact and so on, the consciousness and so on, the major attributor to that is the enhanced observations, improved high-resolution modeling things due to supercomputers, increase in the computational resources, interaction among the operational research and academic communities, and international collaboration. That gave us accurate prediction of cyclones 4 to 5 days in advance, which were not possible in 1999. Next thing that is the media and television and so on. Now you know that we have so many media and televisions, but in 1999, even that time the chief minister, he could not come out of his house for 3 to 4 days because there is no communication. And third most important thing is the disaster management. As I told you, the OSDM in 1999, and then we have NDRF and so on, and then we have a lot of good infrastructure in the village area, in coastal areas, which is highly affected by the cyclones, because previously the mud roads, perhaps you have not seen those things. That time a bicycle cannot come out of the village if there is rain before arriving of the cyclone. But now we have all pakka regions and many shelters and so on. So future strategy that we have to enhance these things. I will again not go through, and I will show you that the success story which I told you that in 1999 when 10,000 people died, with another one, similar one in 2013, that is your Falling, where the forecast is very much accurate. You see that this is a cyclone, the white one, the track, red one is the predicted. It was exactly by 4 days in advance. So therefore, 10,000 people are evacuated from the region of Gopalpur and that side, and the casualty has come down from 10,000 to 20. And this is a thing actually for the thunderstorm, because thunderstorm actually we cannot really evacuate the people because it comes very sudden, but people are in the field, so they have to take some measures so that wherever they are, they should have lie down their height should be as less as possible compared to other even tree and other things, so that like a detector, the cyclone can pass, the thunderstorm lightning can pass through, so the person can be saved. So with this, I thank you all for your kind attention, and thank you. Yeah. Sure.
What is the procedure or how to name the different cyclones? Hudud, Fani, or super cyclone?
Yeah. How to? Yeah, please have
What is the criteria to name the particular cyclone, like Hudud or Fani?
Or the name?
Yes.
Yeah, you said up to Odisha super cyclone, up to 2000, we don't have any name for the Bay of Bengal cyclone.
Yeah.
But cyclones in the Arabian, the Pacific and Atlantic, they have name from long time, but we don't have. But then actually after 99 cyclone and so on, then India, and you see that another thing that the cyclones in the Bay of Bengal, Arabian Sea, they don't come to India alone. Like a Bay of Bengal cyclone, they go to Myanmar, it can go to Bangladesh, it can go to Sri Lanka, it can come to India. Same with the Arabian Sea cyclone, it can come to India, it can go to Pakistan, it can go to Oman, like Bonu, which is. So at that time, these countries together, they decide the names, and the names are given in alphabetic orders, because Bangladesh gives so many names, India gives so many names, Sri Lanka, Myanmar, Oman, and they go on alphabetically. First, it comes the cyclone with Bangladesh, because B is the number one. Then after that comes, like suppose you come India, Myanmar, Pakistan. So every country give a, like we gave the name Nargis. So when our term came, it is Nargis was given. Hudud is given the Arabian countries, and when their serial came, they gave. So they go on rotating that thing. But in Atlantic, suppose, they give in the name of the different people, ladies' name and so on. Yeah.
How they select Fani?
Yeah. Fani, it is a name they selected based on, Fani was the word, its meaning, I think it was perhaps Myanmar or so. So that name they have given. So each cyclone, they put a list of names from each country they get, and out of that they picked up in alphabetic order. First one is coming to the Bay of Bengal. It will come with the name actually that is the Bangladesh being the first. In Afghanistan we don't have cyclones. So B. Similarly, India is I and so. Yeah.
Thank you, sir, for sparing your valuable time and guiding us in this field. I take the privilege to request Professor Dr. Ganapati Panda, an eminent educationist and the former director IIT Bhubaneswar, to felicitate our guest, Professor Dr. U.C. Mahanti. Sir, please.
Already we have felicitated our previous one, the inauguration, so that's why they are not giving.
Yes, sir.
Whitey side, bhai.
Thank you, sir. Our next talk is by Dr. Nabanshu Chattopadhyay, President, International Society for Agricultural Meteorology, on the topic Challenges and Preparedness for Climate Resilient Agriculture in India. At present, Dr. Chattopadhyay is holding the following important assignments: President of International Society for Agricultural Meteorology, Advisor World Bank, Core Member of Service Commission on Agriculture, World Meteorology Organization, Chairperson of this expert team on guiding the to agricultural meteorology practices, World Meteorological Organization. I would like to invite Sir for the talk. Sir, please.
At the outset, thank you very much to the organizer, particularly Dr. Jena, Professor Mohanty, for giving me an opportunity to present. Actually, my topic will be more simpler now because so many discussion has already been made. But one thing is that, as I am associated with the World Bank, Washington, and also World Meteorology Organizations in Geneva. So I am working for both the organizations. So I'll just highlight that how these two organizations are looking this subject and how much investment they are making and what is the global nature of this climate change and what is the regional and also Indian perspective. I'll just discuss this issue very quickly. If you see that this in COP, which has last month, it is there is a strong message has been given by WMO, the Secretary General, that she is telling that it is unprecedentedly this temperature has increased in 2024, and this is a record temperature, this most hottest year. And she was telling that this, gases is very alarming, and also sea level rise accelerating. Then coastal population is threatening because of this, and glacial retreat is unprecedented and damaging the ecosystem and also threatening the long-term water, hundreds millions of persons. And whatever Mohanty Saab has made, that there's extreme events. She mentioned that devastating floods, persistent drought, searing heat stress, wildfire caused major loss of life in the livelihoods around the world. Three organizations, so many organizations are working, but World Bank, this in UN and also United Nations and also WMO is very, very concerned now to how to tackle this kind of thing globally and also regionally. If you see that how UN is concerned, and it is like that UN is not isolating, they are working with World Bank and also WMO and is telling that early warning will be the next challenge. And whenever we talk about the early warning, this adaptations, mitigations will be the highest. And a commitment has been made that each and every person in the world, next few years, there should not be any problem. And also this UN and WMO, FAO, they are working together, and they said that this task has been given to WMO. And what exactly WMO is doing, you see that in WMO it is a global framework for climate service. And they have 5 pillars. And fortunately, the agriculture is the highest priority, then disaster, then water, then health. And whenever we are talking about that global framework climate services, whatever has been mentioned from morning, not just now, that what are the climatic variability, what are the climate change, what could be the adaptations, what could be the mitigations, and all these things should be science-based. That is there. So now is a huge work is doing to WMO is doing in 160 countries, including India also. But this is a very, very Herculean task. Now a new concept is emerging, which is called regional framework of climate service, so that in the region it can be in a high resolution scale, this can be managed. Now, if you see this GFCS, this climate service has taken care of whatever has been mentioned from morning. First one is the consolidation of the knowledge, present, past, and the future, and then the identifications of the type and form of services, and the informations and the climatic impacts, and also sector-wise sensitive sectors, and then development of the products and services, and lastly is this facilitating the effective uptake applications of this product to help achieve the desired. That is very, very important. Whatever climate service, the last statement is very, very important for the users community. Now, another very thing what Krishna Sahab already mentioned about that, this in water, World Water Development Report 2020 is mentioned that in 2050, more than half of the populations in the global region, they will be suffering, some stress will be there. And also this climate change will availability, then quality, quantity, it will determine. So there is a need to rethink how to use this water by judiciously. Now you see, this is the thing which we have collected from the British Library in 1877 and 78. There's El Nino was there. And because of this, India and North China, it's showing that how people have been affected. So we should foresee that what is a climate change. What my first slides was showing that it was anticipated that from pre-industrial to as on today, it will be 1.5. But this year, 2021 itself, though it's a very temporary phenomenon, it is showing 1.5 the global temperature increase. So you can see that if we neglect and if we are not very sincere about this climate change issue, then in future we will be very in trouble. Now this is already Krishnan Sahib showed, but the thing which in the COP24 showed in the last, that is was shown where WM has shown that it is now 1.5. Now, you see that there are different projections are there, but if you see that 1.5, 2 and 4 degree, most of the Asian and African countries will be affected. So we are very, very careful that, subtropical countries may not get as much as affected as the tropical countries like that. And this is the Indian figures actually up to 2015. I have taken from Krishnan Sahab what he has studied that from 1886, 1986, 0.15, 0.13, that temperature is there. But the thing is that in 2040 to 2069, we are expecting 1.39 to 2.7 degree. So that means the momentum will be keep on the increasing the temperature. Now you see that rainfall. We have seen in the 100 years data, Indian meteorological data. We have seen that in rainfall there is different epochs around 30 years. So sometime it is below normal, sometimes above normal. So we are in the positive epoch now. But if you see the spatial distribution, Jharkhand and Chhattisgarh, last 100 years we have seen that there is a severe decrease in the rainfall. Even also in Odisha it is not so much encouraging. But in case of agriculture, we are very concerned about the temporal and also spatial distribution of the rainfall. If you see here, in the month of July, the full Odisha and this East MP, this red color is there. That means, we have to rethink now that how to transplant the crop, whether we have to diversify the crop. Even also, if you see that in August, again, Jharkhand and Chhattisgarh. So, but the favorable will be the western part. But the eastern part, whatever the 100 years study we have made, is not very encouraging. That means this is observed climate change. Now, this is the study we made with, from 1950 to 2016. That in agriculture side, if you know that we have divided the country into 127 agroclimatic zones. Based on that cropping pattern, then rainfall and soil moisture, but soil texture and whatever may be. So we have seen that in 1950 to 1980 and 80 to 2016, there is a definite shift of the rainfall regime and temperature regime. So we have requested Minister of Agriculture that they have to make again review this how to classify Indian agriculture system into agroclimatic zone. Now, changes in the rainfall, what already mentioned that we will be having, monsoon will be weak, but moisture content will be relatively high. So as a result, monsoon will get rainfall, but the rainfall will be very short span will be there. And also this central India, more prominently over central India and southern parts, enhancing warming will be there. And also another very important thing for the agriculture aspect that monsoon onset. So it has been seen that from a study that monsoon onset will be early or may not be much change, but withdrawal will be late. That means the lengthening of the Kharif season will be there. So a lot of thinking will be there that how to select the crop, what time, and another thing that whatever already mentioned that though rainfall will be more, but intra-seasonal and inter-annual variability will be there over the Indian region. Now this is the project climate change will be there. This is a scenario generated, but if you see that the rainfall will be 6, 10, 9, 14, it will be increasing, but different scenarios already been discussed. But another thing is that, whenever we are talking the climate change, every year we have seen that climate variability. Early onset, then heat wave, erratic onset, active spell, break spell will be there. That is also a major concern. And some schools of thoughts are that this climate change will also make a lot of things on the climate variability aspects. Now, this is the devastating stage. When we go to the local scale, we have seen that when cyclone is coming or any other climatic variability will be there, farmers are very, very, they don't know in the rural areas what are the, though there are some advancement is there, but still today this is number of crops, maybe horticulture, maybe cereal is affected. Now we know that though a lot of discussion, lot of meetings, lot of is there, but still there is an inadequate response of climate change is there. So this is the right time that we have to sit together and see how to mitigate, how to take an adaptation plan like that. Now, what Mohanty Saab has said about that extreme events, this is very, very true. And that particularly the two region, one is the West Bengal, Odisha and Tamil Nadu, Andhra coast, and another is Maharashtra, Gujarat coast. They will be affected by the cyclone. If you see these things, one of the reason is that sea surface temperature. And in Indian Ocean, sea surface temperatures has increased to 1 degree. But world average is 0.7. That means Indian Ocean is warming very fast, and it has been already mentioned that frequency we don't know how it will be there, but whatever the cyclones will be there, they will be very, very intense cyclone will be there. It will be very, very difficult to tackle. So there will be a constructive plan should be there how this Maharashtra and Gujarat coast and Indian and also Odisha, West Bengal should be tackled in the highest priority. Now you see this, whatever the projections are there in Arabian, in Indian Ocean, there will be an increase. And this is a study we made. This will be very, very important for the agriculture point of view, that whenever we have a cyclone or heavy rainfall, the soil is eroded. So with NASA and 26 countries, we have worked with the heavy rainfall, and we have calculated erosivity. That means how the soil erosion is there. if you see this one, this is the blue color and green color. So even our northeastern region is very, very in danger now, because most of the soil is getting eroded because of this heavy rainfall, flash flood, or whatever it may be. But in the eastern part, Odisha, West Bengal, we are still in a green part. So what I was mentioning that government of state government and also government, central government, they should not they should take care very seriously that if this action is not taken, as on today, then this green color may be blue color. Then you may not have much chance to do. So whenever I am going for any kind of seminar or interactions, I was just trying to convince that the soil erosion in future in India will be great concern. So now another thing is that river bank erosion, when flooding is there, is eroded, and so many fertile lands are going into the so in Bangladesh, this Padma and Meghna, 2 kilometers they have encroached into the land. Even also in Odisha and also West Bengal also. So this also has to be taken in a very serious issue. And we have also given what are the protective kind of things. I will not go detail of this, but this riverbank erosion, there is some temporary and permanent solutions are there. So major initiatives should be taken at the state level and also at the central level for the permanent structure, also by planting of and also a lot of afforestation should be there. Now, another very interesting thing is that we cannot use this land, coastal area, because of storm surge and causing the salinization. But a lot of adaptations and mitigations is ongoing. And under NICRA project, they have developed some of the salt-tolerant crop. Even also, there are some measures are there how this groundwater can be reclaimed by this thing. So, but the thing is that this should be implemented at the ground level, so that the coastal belt, the populations are there. A lot of advertisement, lot of awareness program from the state level and central level should be there. How they can grow the crops, because you cannot stop what Mohanty Sahab has said. You cannot stop cyclone. Cyclone will be coming, and it will be more and more. But we should take a kind of protective measures. Now, cyclone warning, what I already mentioned, that now 5 to 7 days before we can say the landfall, and because of Doppler radars and satellite numerical weather predictions. So this is a great achievement of Indian Department, MOES, and with the state level agencies like that. This is the things which is in reality actually that how the track has been done. So what are the extreme? The cyclone could be managed, but again, 5 to 7 days is very difficult to do for the agriculture front. You can do so many, rescue or something. You can shift the animals also. But again, we want that more lead time should be required for the cyclones. Another thing is the drought, which is also very, very important phenomena. And we have seen that from 1951 to 2016, Central India, Kerala, and South Peninsula, this drought is very, very prevalent. And projections also showing what we have studied actually that in 50 years, for paddy transplanting for July is very important, because latest by first week of August we can transplant. But if you see the July, this I'm showing the left hand side, the break monsoon in 78 to 2003. you see in July there are 39 breaks. And when the breaks are there, so you cannot transplant because you cannot, waterlogging will be not there. So this is a very major cause of concern about the diversification of our crops or like that. And the right hand side, I'll show you that in detail that we are only seeing that how rainfall will be there. But another very important parameter is the evaporations and the potential evaporations. How much water is coming out of the soil. So they should compensate each other for the soil moisture. So, in my study when I was in London, I worked with the crew, and we have taken the 7 kind of model where we have shown that in future the evaporation and potential evaporation will increase. And but in the post monsoon, in the south region, which is already problem in the water, more problem will be there. So we had studied that in the monsoon, what will be the compensating P and P will be there. If you see in the monsoon, that eastern region, we will be slightly safer side where we can get the moisture. But post-monsoon, we don't have. Even also in monsoon also, the southern part will be at risk. So this is the kind of indications, this how you can manage the soil moisture, how we can make more water water harvesting, so many things. So my intention is that about the implementation parts. This is the thing which is with the observed climate change and the future climate change. If you take into considerations about the agriculture point of view, we have to do a lot. Another thing is that it is not only the climate service, the weather service. What we are doing for the tactical decision. Indian Meteorological Department with universities, we are doing called Agromet Advisory Service. That is, we are taking for 7 days forecast, and we are telling the farmers what's supposed to do. But this makes a lot of problem into that. In 2016, 17, this in Maharashtra, this Marathwada region, we have said that you start sowing soybean and cotton. But after that, dry spell has started coming, and all the crops has been damaged. Then there is a lot of in the administrative problems has coming that kind of forecast has been given, which is not very ethical for the farmers. Then also, but we are also that time working on the experimental mode about the subseasonal forecast with the IITM. So after that, we have started Indian Met Department and universities that to start the subseasonal forecast. Now farmers are now comfortable, but again the issue is that resolution. Within the districts also there is some problem in the forecasting. So we are advocating that forecasting group that give the correct forecast, keep the skillful forecast or the high resolution. So a lot of investment has been made in Indian Met Department to do this for the Indian context. And under climate change scenario, this will be very, very important. And if you see that as far the drought is concerned, number of indexes is there, and now that SPI is working fine. 150 countries are working on SPI for drought monitoring. And also, if you see this picture very carefully, that throughout the world we depicted what will be the drought status will be there. If you see that only one part, that is North Australia, they will be the positive where no drought is there. But in Middle East and even South Africa will be having a drought. But South Asia region where we are here, our data are also is not that much, so that nothing could be said at present what will be the drought status. But as per the projections, it is that it will be increasing. Next is that, flood. Flood also, it will be increasing, but most of the flood will be the Himalayan river basin, Indus, Ganga and Brahmaputra. And then whatever the flood, the maintenance is there as on today in India. But again, some of the floods are very transboundary in nature. In Kushi River from Nepal, inundating Bihar, like that. Okay, so we have to think more the flood, how flood can be controlled, and there are some different, when the flash flood is there in Meghalaya, also in Bangladesh. So we have developed that what kind of system should be there, so that the runoff can be minimized, put into the watershed system, and that water can be reinvested into the farming. So again, this is the warm days and warm night and the cold night. So warm days will be more. So there's a milder decrease in the cold days will be there. So this is also very, very sensitive for our crop, which are the sensitive for the temperature, even also the pest and disease. Whatever, as you mentioned by Mohanty Saab, that this Damini project is doing 20-kilometer resolution, but again, for climate change issue, there will be a lot of problem will be in the weather sectors also. So more accuracy and more resolution will be there in that. Now, this is another thing is the pest forecasting. When the climate change is because climate, pest and diseases are very, very sensitive to temperature and humidity. So whenever the climate change will be there, this will be also be affected. Mostly the transportation of the pest and the physiology will be there. So here also a lot of study is required about the pest disease problem and the climate change. And also animals, we have seen that if there is a temperature increase and stress in the animal, the huge reduction in the milk, and also so there are different indexes are being used now. So more studies are required for the animal sector also under climate change. And as far the agriculture is concerned, I will show some of the figures where how this climate change will reduce the wheat and rice productions in country and which region, and also this whatever the things is going on, how the climate information is giving a decision support system in terms of climate impacts, climate resiliency, demand for climate information, and various types of users, how they will be using, and different types of adaptations and mitigations. I have just mentioned it here. Then these are some kind of the adaptations about the crop improvement, risk financing, drought proofing, disaster management, new varieties, new farm management, change in land use, watershed management, and agri insurance. Now, climate smart agriculture is coming in a big way under the climate change issues. Here, all the kind of features I have mentioned has been taken together, and these four aspects for better production, better nutrition, better environment, better life for all. This has been taken as the four pillars in the climate part. The important part is that World Bank is investing a lot of money on climate smart, and under the Paris Agreement, they have increased the investment 8 times about. So if anybody is interested to work on the climate smart, and so they can approach to World Bank to take any kind of projects. So whatever just I have mentioned, that climate information, weather information, how to reach to the farming community. So there are 44 projects are there in India, and this called Agro Advisory System. This is called one of the projects, and Prime Minister himself is also monitoring. I know I have seen that in one of the science congress he was mentioning about how this information is going to the farming community. So here, this is the structure of the agromet services in India, and how this services is going from the from satellite, from the IMD to the farming community, and how the farmers are taking the actions. And here also we are trying to increase because the weather will be so much sensitive. So we are trying to introduce artificial intelligence into our systems with the data and with this. So this is a kind of artificial intelligence we are doing. How best of the short time we can give a very skillful, focused, and also the transform the forecast into the adversaries. So even also, if you see this, how artificial intelligence is coming, a farmer is sitting in his field. So with our cloud server and whatever the observatories are there, we are putting everything there, and we are from cloud server we are putting these things to farmers' mobile. So very, and also with we are trying that how remote sensing kind of high resolution informations can be tagged into our system. So this is also is an ongoing process there. And also another thing is that we can generate so many things, but a farmer sitting in the village, he should know that what will be happen today night, so that he should not irrigate. Or if he know that pest and disease will be there after 3-4 days, he should know. So the dissemination is very, very strong in India now, and the South Asian countries is following now India about the different kind of dissemination channels we are doing. Now, whatever we are doing, but the challenges will be there in future, as well the climate change scenario will be approach to future climate scenarios, alert system, co-production of the service, and evaluation of agroclimatic service and capacity building. So a lot of capacity building is required now, whatever I have just mentioned. And this is the things which I was talking about, that in 2016 another incident was there, that there's a huge hue and cry in Maharashtra that a lot of whether farmers will sow the crop or not. Then that time Prime Minister Devendra Fadnavis was there, so he called us and said that I have to address to the farmers of Maharashtra, you please tell what we are supposed to do. We are very, very happy to learn that this highest administrator in the state is consulting with us. So with our own knowledge, we said that next 2 weeks there should not be any sowing operations. He said that I will inform from my office this thing. So, and he has done it. So this is the creativity that Indian scientists, climate scientists and agriculture scientists is working together. Now, we believe on the success stories, whatever we have done. So we are making extensive success stories. It may be horticulture, crops, or like that. So based on this, we are informing the highest authority, Government of India, and that is why this scheme is now continuing. Now, some of the success stories, I just mentioned it here because every 5 years we have to give the report to the Government of India. If you see that the economic benefit of agro-advisory is now reaching to 24% of India's farmers, and also 50,000 crores annually we are getting. But if all the farmers are getting this kind of privilege, then 211,000 crores will be there. So that means, under climate change scenario, this kind of services will take a major lead in the country, not by the particular, but institutional mechanism it will be doing. And I will just keep that whatever I have just mentioned about that, how to use the water. And this is very important part, that what I mentioned, that uh, we have to work on a very multidisciplinary approach, and if you see that how this water will be used in India by watershed management, water budgeting, groundwater mapping, direct seeding, water efficiency. So all these kind of measures will be taken into system, so that whatever the water we are having, what we can preserve, we can use judiciously. Now, this is a NICRA project already been mentioned, that NICRA projects is doing also for crops, livestock, natural resources. Here component will be strategic research, technology demonstration, capacity building. Then, this is a natural based solutions to the climate change on agriculture. One is that grazing optimization, improve rice cultivations, crop nutrient management, conservation agriculture, trees in the cropland. So all these kind of informations are available. Now we have the responsibility how to mobilize this information to the farming community. So this is the flood tolerant varieties already been developed, then crop diversification, then response to extreme events, all the case studies I have just presented here. Now mitigations already been mentioned. Then this is very important, how we reorient our policy. In Punjab we have given a lot of subsidy-based approach, but that was not very fruitful. Even diversification of crops, which we have discussed now, and also what I just mentioned, the World Bank projects is going on in India, and it will in future. So we have to tag to the World Bank project, in particularly climate smart agriculture, what best we can do. Another is that community approach, that is the participatory irrigation management and others. So another will be insurance, because even also if you do all these things, you have to get the confidence in the user sectors that they will be obliging you, but whenever there will be loss, they should be supported. The thing is that we have created knowledge pool recently, last 3 years, called South Asian Forum for Agriculture Meteorology. 9 countries have been involved into the system, and we are discussing each other. If any problem will be there, it may be climate variability, whatever may be the issue, how this forum is helping to this agriculture. Another is that called International Society for Agriculture Meteorology. So where also we are addressing different continents, even also South Asia, even also India. We are now very supportive. I have said that a particular country, they can't do all this, whatever the gravity of the problem is coming. So a knowledge pool has to be taken at the regional level and also global level to resolve the problem. We had a meeting, in the WMO last month. We have discussed in detail different kind of problem in different continents. So 16 countries and 19 participants, we have discussed that what are the challenging problems are there. And I have given 2 proposals in that. This one is that I have mentioned GFCS, Global Framework Climate Services, but I said it's a Herculean task, it's very difficult, but if we can take it to regional level. So we are discussing with Ministry of Earth Science, with WMO, and also this is forum, that how best of this forum can support even also deemed university like yours. If you can be with us, WMO, World Bank, we can see that what about if you have a tribal problem, how to resolve this tribal problem, taking the world knowledge pool into your system. Even also another things I have said, that research and excellence, how this can be made in South Asia, and taking considerations of the best countries in the world. So this is a very, initial concept of the RFCS. We are trying that SAMA and SAFAM, I just mentioned, this knowledge pool, and they will be working with regional bodies called RA2 region. This is 35 countries are there, Middle East, South Asia, Southeast Asia. So 35 countries, and GFCS pillar I mentioned about the 5 pillars, and strengthening of regional cooperation. So this, and we'll be having a meeting in February in Delhi about how this RFCS implementations. Already we have a discussion in the last month. So here also, my purpose of coming it here, that how this university or anybody he wants to join such kind of innovative approach, they can interact with me and others. Now, whatever I have just mentioned about the resilient agriculture, recently we have published a book by the Springer, where WMO, who is the chief in WMO in agriculture and meteorology, he is there, Robert Stefanski is there. So around 16 to 20 countries, they have given their kind of what exactly they are doing in their country, how this resilient agriculture can be done. If anybody interested, he can take this and I'll be students to read the book. Another things we have done called smallholder folding farmers, how they can be benefited by climate services. This is also available in economic and there are so many, if anybody is interested, he may contact me. I can share so many informations to you. Now, conclusion and recommendations is that we have already showed that how this climate service can do for the climate change, climate variability, different strategies. But again, I'm telling that these strategies and also the challenges should be taken together with the multi-institution. When I'm taking multi-institution, maybe national or maybe the international, we have to think of it. And this recommended that preparedness strategies are taken serious at the local level and also the regional level. And one thing is missing actually at the local level, we don't have that much of assessment report on that of the natural disaster, maybe like that. So we need this kind of assessment study, because that will help us too. So this may be a project among the collaborating organizations, how to assess, maybe in tribal area we can assess what exactly is happening, and then what kind of services required and how replenish this kind of services. Now, my last slide is that what is the way forward? Way forward is very, very focused that climate informations, agromet informations, to better agriculture service, weather service in agriculture is a viable options to mitigate this kind of challenges. And all of the hour. More multi and bilateral agreement among organizations at national and international level is desirable to exchange ideas, technology, to reduce the impact. Then use agroclimatic forecast based on combining subseasonals. Still today, we are not using seasonal forecast in agriculture. South Africa is using because of different reasons together. But a strong group should be there who should give a kind of outlook about the seasonal forecast. Even today, we have a SASCOF where they are doing seasonal forecast, but resolution is very, very big. It's very difficult to do. When I was talking to the Secretary of Agriculture, he was asking me, can you give the skill of your forecast so that I can mobilize my instrument in the state level? So there is a lot of kind of, interactions, meetings is required. Subseasonal forecast we are doing now, and we are introducing in South Asia now. Then correct use of agromet tools together with constant dialogue between farmers and scientists may become an effective mechanism to reduce uncertainty level of farmers' vulnerability. Then programs for improving prediction method dissemination should be expanded intensified. And last, we must recognize that successful implementation of this type of strategy depends on progressive process of sensitization. Last year we made 2 sensitization program in Nepal and Afghanistan, where this kind of concept is not there. They are when the extreme event is coming, crop is damaging. They just simply see what is. But we have made a sensitization program with the ministers in Afghanistan and Nepal. Now they are very, very interested. They said that the SAFOM and SAMA, if they can come together, we will invest money and we will do this thing. So that's why I'm telling about the successful implementation of this type of strategy depends on progressive process of sensitization, even at the policy level, which is in policy level still, a lot of things to be done. Our scientific level, we are doing a lot, but still today there is a lot of gap of the scientific level and the policy level. I think a lot of sensitization is required at the state level and the policy at the central level. Learning and adaptation, farmers and scientists working together. Though it is very difficult to say about the climate change, climate variability, what should be done, what is the present status, what is future. But I have tried to give a kind of idea, but I will appreciate if anybody, maybe student, maybe anybody, if we can sit together, work together about the implementation strategy, the high resolutions, whatever possible, I'll be happy. And I'll be happy that if anybody is coming to World Bank, UNDP, or maybe World Meteorological Organizations, so I'll be extremely happy that if we can. Ultimately, we have to do, because now after 2050, there not much time will be there to control the climate change impact on the agriculture. So thank you very much for giving me opportunity.
One very valid point. You raised that regarding the soil erosion and the river bank basin and the past flood. See, at Bhubaneswar also, people are dying also. Moreover, regarding the river encroachment, I stay in Cuttack, in between 2 rivers, Mahanadi and Katilbek. Now they are encroaching Mahanadi, and 5-10 lakhs people are celebrating Bali Jatra. So this body should recommend to the government, this should be stopped. In the morning section of our speaker, they also raised this issue. River has to be protected. So I request Dr. Jana to give a strong recommendation to the government that because the river is a great source of water for irrigation and drinking. So this must be strongly recommended and get to the government. Can you highlight this point? 1 minute.
This is a very valid point. Not only the river bank erosion, even soil erosion, because a lot of fertile soil is going to the river and the ocean. Okay, so both, even also now it has been scientifically proven that Orissa, it is in green color, but time will be not much because we have already projected that intensity of heavy rainfall will be more and more, cyclone will be more and more. That means when heavy rainfall will be there, more erosions will be there. So this green should not be blue, and for that you have to take a lot of measures. I have mentioned all the measures, and I'll be happy if Jana can share what are the measures to the state government, and also even also in government of India, they are having a soil or water conservation project. They can take the kind of thing based on the scientific proven which has been done by NASA and other countries. About the river bank erosion, I have seen that most of the river bank erosion, they are making a temporary measures, making with the mud and something like that. So I think that in Orissa and West Bengal, there should be a kind of, a body should be there, form should be there, where they can talk to the scientists and see that what should be the permanent solutions to that kind of afforestation, kind of permanent structures like that. But only the problem is that, when the flooding is coming, only then the state government and central government is very kind of sensitiveness is coming to that. But rest of the period, they're very, very silent. So I think there should be some kind of group will be there, some task group will be there formed in Odisha, and also in West Bengal, where it is. Even also the same thing is happening in Maharashtra and Gujarat, where land after land is getting salinized because of the storm surge. Okay. And the farmers are not doing anything and make that fallow, and they go for mixed cropping now and for livestock and others. But why to do? When we have NICRA project, we have soil tolerant, and we have the technology of refining the groundwater. Why not take? My question is that we have the technology, but it is not coming to the policy level to implement this. But now the stage has come that it should be implemented in the policy level as a case study to show that what best we can do these things. So my will be that this kind of conflict should not end today, it should the beginning, and we should work together. And I'll be very, very happy that if I'll be in this group and can contribute.
Okay, thank you.
Thank you for your generous lecturing on climate change versus agro-agricultural condition. But is it giving the fruitful as an output towards the global? That is 0.5% only. So what is it necessary unless you develop the new technological innovation? So on this link, I have to say that for this global climate change, the patent already done on 762023 on greenhouse gas, that is carbon dioxide, methyl, chlorofluorocarbon, other gas, NH3, etc. by innovative method. That is patent number is 20233103897. Another for disaster management, that is the meteorological disaster machine, that is patent on 15042023. That is application number is 2023310255751. That is the best output to eradicate any meteorological disarrangement, say your fast flood or cyclone, funny, hurricane, etc. As well as another patent machine, that is predication.
Excuse me. What is the specific question?
Specific question that you elaborated so much long time on climate change versus agricultural development, that is not fruitful to global wise or regional or local wise, that is giving only 0.5% only, or not. That the rest 99.5 only unlimited. So this machine will any scientific innovative temper innovation, it cannot be fight against your agriculture fruitful.
The innovation is must, because I totally agree with you. Innovation is must. But the thing is that innovation is coming in a very step by step. Because now we have a projections, we have the assessment. Okay, we have institutional arrangement now. Now the thing is that based on that, just like I was telling about that, if you reclaim the soil, or if you make the erosions to be controlled, the innovations is that still today.
No sir, such type of
okay, I can see to
we
it.
Cannot erode your soil component.
Okay, I can sit with you and discuss. Yeah. Yeah, you can discuss. I can sit with you.
Right, we will end up here, but fact is, friend, agriculture, forest, the landscape and the season, the type of cultivation. When we say agriculture, in rice, you have got summers rice, you have got wetland rice, you have got dryland rice, you have got mediumland rice. So it's not that easy that you find a single solution. That's why every season, every place differs. That's the real reason. So it's not the tribal. We are definitely devising things, but that suits to one thing, like a small weeder. Try to understand. If I try to turn the plain land, that's what. So I think, sir, should we end up here? Thank you, sir. Let's break for lunch. Thank you very much, sir, for
Thank you, sir. I'd like to invite upon stage Professor Dr. Bansidhar Majhi, former VC Visud Burla and present VC of C.V. Raman Global University, to felicitate our guest.